So in this particular problem, we have a boat of mass 200 kilograms that's experiencing a constant forward force of 120 newtons and a resistive force of 25 V newtons. Now, we're told that the boat starts from rest at the origin. So the first thing we're going to do is we're going to compile a free body diagram. So let's go ahead and draw the weight first. We know it weighs 200 kilograms, so 200 times gravity. We know there's some kind of buoyancy force keeping it afloat. I'll call it reaction force for simplicity. We have a forward force of 120 newtons pushing it forward, and we have a backwards force of 25 V. So the backwards force changes with speed, the forward force is fixed. Now we're going to use Newton's law to derive an equation of motion. Now remember, this thing is going this way. Newton's law states that the sum of all the forces is equal to mass times the acceleration. Now we're looking at the x direction. Since the boat is moving to the right, we're going to pick right as positive. Therefore, 120 is positive, is in the direction of motion. The resistive force is negative, is equal to the mass, which is 200 multiplied by A. Another way of writing A is dV over dt. Now, when you're manipulating this in order to separate the variables, whenever you have a plus and a minus between your forces, you have to keep this together at all times. You can't separate this because it won't help you. So we're going to multiply both sides by dt and divide both sides by this bracket here. So we're going to get dt is equal to 200 divided by 120 minus 25 v dv. We've now separated the variables, so the v's are on one side and the t is on the other side. Now you can go ahead and integrate both sides. Now, in order to integrate this, we have to use our fraction law, and the fraction law states that if you want to integrate a fraction, one way of doing it is that if the top is the differentiation of the bottom, then when you integrate that fraction, it's equal to ln of the bottom. That's the easiest way to put it, really. So let's have a look at our fraction here. Is the top a differentiation of the bottom? Well, let's differentiate the bottom. When you differentiate this, that becomes 0. That becomes minus 25. Now, this is not minus 25. This here is 200. Now, how do you make this minus 25? Well, we can separate this into minus 25 times something else. So, first of all, let's make it 25. So that stays the same, nothing changes there, dt. In order to make 225, we know that 200 divided by 8 is 25. So if you take 8 outside and have the integration sign, you're left with 25 divided by 120 minus 25 v dv. That's how it's going to work. And the way you test it is multiply these back out again. 8 times 25 goes back to 200. So we haven't changed anything. And the reason we did that is because we need 25 on the top as well. So the easy way to do that is look at the number you need, divide that by the number you need, and put that number outside. That's the easiest way to put it. Now we still need a minus though. So to put a minus, just multiply by minus, and multiply both sides by minus. Now let's go ahead and continue this. Integration of dt, don't forget the minus, is minus t is equal to, the 8 stays outside. Now because the top is a differentiation of the bottom, we can go ahead and use this, so it becomes ln of the bottom. Ln of this, 120 minus 25 v plus a constant of integration. Now in order to find a, we're told the boat starts from rest at the origin. So when time is 0, the velocity is 0, starts from rest. That's going to become a ln 120, that's going to be 0, plus a. Therefore, a is minus 8 ln 120, minus 8 ln 120. Now, put this a back inside this equation, back inside the a. So your equation now becomes minus t equals 8 ln 120 minus 25v minus 8 ln 120. Now, these two 8's here, we can take them as a common factor. So what we can do is we can say minus t equals 8, open bracket, these two lns here. What that allows us to do is it allows us to use minus ln 120. What that allows us to do is to use the laws of logarithms to combine these two together. Now we can also move the 8 here, so divide both sides by 8, it goes on this side. So you get minus t over 8 equals, these two are minus. When you minus two logs, they become divide. So it becomes ln 120 minus 25v divided by 120. Now, in order to make v the subject, what you must do is you must use exponential law. So the exponential law states that e to the power all of this here is equal to everything next to the ln. That's the easiest way to remember it. Divided by 120. Now, what you can go ahead now and do is simply simplify all of this and make v the subject. So in the end, you're going to multiply both sides by 120, then go ahead and move the v to the other side, and then make v the subject. So we're going to go ahead and do that now. So start by multiplying both sides by 120, so it becomes 120 e to the minus t over 8 is equal to 120 minus 25v. Now move this to that side and this to that side to make the v the positive. 25v equals 120 minus 120 e to the minus t over 8. Here we can take 120 as a common factor. We can divide both sides by 25. So here we get 120 as a common factor. So that makes that 1 minus e to the minus t over 8. Just factorizing this basically. And don't forget to divide by 25. 120 divided by 25, 24 over 5. 1 minus e to the minus t over 8. Now the question wants to know the speed of the boat after 10 seconds. So all you do is substitute 10 into this equation and solve. Once you've done that, you will get a value of 3.42 seconds.